What is ArrayList and how it works? ArrayList is a dynamic array-based implementation of the list interface. It provides a resizable array that can grow dynamically as elements are added. Unlike regular arrays, ArrayList automatically handles the resizing of the underlying array as needed. Let's understand ArrayList with an example. In this example screenshot, we create an array list called numbers to store integers. We add elements to the list using the add method. Elements can be accessed using the get method, and we can update elements using the set method. The remove method removes an element from the list. The contains method checks if a specific element exists in the array list. The size method returns the number of elements in the list. Finally, we iterate over the elements in the array list using a for each loop. One of the key advantages of ArrayList is its dynamic resizing capability. When elements are added, the array list automatically adjusts the underlying array size to accommodate the changes. This provides flexibility in handling collections of varying sizes without the need to manage the resizing process manually. Note that ArrayList allows duplicate elements and preserves the insertion order. How do you create a list? We can create ArrayList by calling the ArrayList constructor. We can also create other list classes, which implement the list interface: LinkedList, stack, vector, and copy on read ArrayList by calling their constructors. How do you add elements to a list? To add an element to a list, we can use its add method. How do you access an element at a specific index in a list? To access an element at a specific index in a list, we can use its get method. How do you remove an element from a list? To remove an element from a list, we can use its remove method. How do you check if a list is empty? To check if a list is empty, we can use its isEmpty method. How do you find the size of a list? To find the size of a list, we can use its size method. How do you check if an element exists in a list? To check if an element exists in a list, we can use its contains method. How do you iterate over a list in Java using a for loop? In a classic for loop, we can get each element using its get method till we get all the elements in the list. How do you iterate over a list in Java using a for each loop? Though for loop gives a greater degree of control over an iteration, the for each loop is better in terms of performance as it uses closures. It is recommended to use for each if you simply need to go through all the elements of a collection. How do you iterate over a list using an iterator? This is an example code to iterate over a list in Java using an iterator. How do you sort a list? To sort a list, we can use a collections.sort method. It sorts the specified list into ascending order according to the natural ordering of its elements. The time complexity is n log n. How do you reverse a list? To reverse a list, we can use collections.reverse method. This method runs in linear time. How do you find the maximum element in a list? To find the maximum element in a list, we can use collections.max method. How do you find the minimum element in a list? To find the minimum element in a list, we can use collections.min method. How do you remove all elements from a list? To remove an element in a list, we can use its clear method. How do you convert a list to an array in Java? We can use its toArray method to convert a list to an array. How do you convert an array to a list in Java? To convert an array to a list, we can use its asList method. How do you find the index of an element in a list? To find the index of an element in a list, we can use its indexOf method. How do you check if two lists are equal? To check if two lists are equal, we can use its equals method. How do you shuffle a list? To shuffle a list, we can use its shuffle method. What are the different implementation classes of list interface? Several classes implement the Java list interface in the Java Collections framework. Some commonly used implementation classes of the list interface are ArrayList. It is a dynamic array-based implementation of the list interface. It provides fast random access and is suitable for adding and accessing elements. It dynamically resizes itself when elements are added or removed. LinkedList. It is a doubly linked list-based implementation of the list interface. It provides fast element insertion and deletion, but slower random access compared to ArrayList. It is useful when frequent insertion or removal of elements is required. Vector. Vector is a legacy implementation of the list interface that is synchronized, meaning it is thread-safe for concurrent access. It is similar to ArrayList but with synchronized methods. It has slower performance than ArrayList and is rarely used in modern applications. Stack. It is a specialized implementation of the list interface that follows the last-in, first-out principle. It provides operations such as push, pop, and peek for stack-based operations. Copy on write ArrayList. It is a concurrent implementation of the list interface that allows multiple threads to read the list simultaneously without external synchronization. When modifications are made, it creates a new copy of the underlying array, ensuring thread safety. These implementation classes provide different characteristics and performance trade-offs. You can choose the appropriate implementation for efficient list operations, depending on your requirements. What is the difference between ArrayList and LinkedList? The main differences between ArrayList and LinkedList are the underlying data structure and the performance characteristics for various operations. Let's first talk about the underlying data structure difference. ArrayList is implemented using a dynamic array that grows and shrinks automatically as elements are added or removed. Elements are stored in contiguous memory locations. LinkedList is implemented as a doubly linked list where each element contains a reference to the previous and next elements. Let's talk about performance characteristics-related differences. With regard to random access, ArrayList provides fast random access to elements based on their index. Retrieving an element by index takes constant time. In LinkedList, accessing an element by index requires traversing the list from the beginning or end until the desired index is reached. It takes linear time. With regard to insertion and deletion, in ArrayList, insertion and deletion of elements at the end of the list are fast, as it only requires updating the size of the array. However, insertion or deletion at the beginning or in the middle requires shifting elements, resulting in slower performance. In LinkedList, the insertion and deletion of elements at any position in the list are fast, as it involves updating the references of the neighboring nodes. It provides constant time for such operations. Regarding memory overhead, ArrayList has a smaller memory overhead than LinkedList because it only needs to store the elements and an internal array to hold them. LinkedList has a larger memory overhead due to the additional memory required for storing references to previous and next elements. To summarize, ArrayList provides fast random access to elements and is efficient for adding or removing elements at the end of the list. On the other hand, LinkedList excels in fast insertion and deletion at any position, but has slower random access. The choice between ArrayList and LinkedList depends on the specific requirements of your application and the type of operations you need to perform most frequently.